So I'd like to help you guys out with making all of these transitions between your position versus time graph to your motion map and finally down to your velocity time graph. The first thing you need to do is to be able to understand what the motion of the object is. So what I've written down here are 3 points that I would think would be important to know. First of all, the object starts at 0 meters at 0 seconds. Next, the motion of the graph from 0 seconds to 5 seconds changes 5 meters for every second. Finally, it stops for 5 seconds. This covers the full time of my motion of 10 seconds. In order to change this into a motion map, I need to think about where I am every single step of the way, and you'll notice that this is meters. Sometimes people are confusing this for seconds, but it's not seconds, it's meters. It's my position, which is this up here. So if I consider where I am for every single second, because I must have a dot for every second, if I look up here, it's almost as if I have coordinate pairs. At 1 second, I was at 5 meters. At 2 seconds, I was at 10 meters. And I'm going to translate that down here. I put a dot for starting at 0, and I know that my first second, I was at 5 meters. My second, I was at 10 meters. My third second, I was at 15. Fourth, I was at 20. Fifth, I was at 25. And then I can draw my arrows. It is okay to leave a little bit of space between your arrow and the next dot. They do not need to connect. Once I reached 5 seconds, I stopped for 5 seconds, so I need to indicate that with a dot. To make sure that you have enough dots, you might want to consider numbering them. So this is 1 second, 2 second, 3 second, 4 seconds, 5 seconds, 6, 7, 8, 9, 10 seconds. That way I know that I've gone as far as I need to go. The next thing we need to be able to do is translate this motion into a velocity time graph. How do I figure that out? First, I need to know what velocity is. Velocity equals the change in position over the change in time. So if you look at your graph from above, you'll notice that you have two different velocities. You have a velocity from 0 to 5, and you have a different velocity from 5 to 10 because the slope of the graph changes. So let's go ahead and look at that first portion. From 0 to 5 seconds, that's my change in time. I go from 0 to 25 meters. So it's final position minus beginning position. What I end up with is 25 meters over 5 seconds, which is equal to 5 meters per second. So if I look at this, my velocity is equal to the slope of my graph. So it's two different ways of thinking about it. Now, this is for 0 to 5 seconds, and then at 5 seconds, my motion changed. So if I look back at my position time graph, from 5 seconds to 10 seconds, my position never changed, which means my velocity is 0. The slope of this graph is also 0. So it's 0 meters per second from 5 seconds to 10 seconds. So if I come down here to my velocity time graph, you notice that I'm starting at 5 meters because this is my velocity. So 5 meters per second, and I maintain that for 5 seconds. So it's this whole space right here. And then what happens for the next 5 seconds? It's at 0. So I come down here and I would continue my graph on until it reached 10. You'll notice that I don't have 10 on my x-axis, but that's okay. So think about what you're doing. First, you're looking at your position time graph and you're describing the motion. This sets your brain up for being able to translate that into a motion map. A few important things. Each dot equals 1 second. So you need 1 dot for every second of the graph. If I have 10 seconds here, then I should have 10 dots here represented by each second. This dot right here is at 0 time. So that doesn't mean that that's 1 second, that's where I begin. And then finally, when I go to bring velocity into this, velocity on my y-axis is looking at this information here, the slope of the graph. Rise is meters, run is seconds. So if I look here, position over time, meters per second, that is how I figure out the velocity. And then I just translate that into my graph down here.